Right now, someone is grinding through their third set of crunches specifically to burn away their belly fat. It is the single most common question in fitness. Can you actually target where your body loses fat? Scientists have tested this exact question repeatedly for over 50 years, yet almost nobody knows the real answer. Testing spot reduction scientifically is notoriously tricky because human bodies rarely isolate work to just one side. You cannot easily force someone to exercise only their left leg for months while leaving the right untouched. Then, researchers realized a perfect group of subjects had been running this exact experiment on themselves for years. Professional tennis players subject one racket arm to millions of intense contractions while the other arm stays relatively idle. Both arms share the exact same diet, the same blood, the same genetics, and the exact same systemic hormones. It created a virtually flawless natural experiment for human fat loss. In 1971, researchers Grant Gwinup, Reg C, and Terry Steinberg published a landmark study at UC Irvine. They published their groundbreaking findings in the prestigious journal Annals of Internal Medicine. Researchers carefully measured both the circumference and subcutaneous fat thickness of both arms across every single subject. First, the muscle results proved that the physical training load was immense. Male players had a massive mean forearm circumference difference of 2.25 centimeters between their dominant and non-dominant arms. Female tennis players showed a significant forearm circumference difference of 1.15 centimeters. In the upper arm, the difference was 0.95 centimeters in men and 1.05 centimeters in women. Years of one-sided, relentless athletic training had undeniably rebuilt the muscular structure of one limb. Then, researchers checked the fat thickness sitting directly on top of those working muscles. The fat results revealed a completely different story. There was absolutely no significant difference in subcutaneous fat thickness between the heavily trained arm and the idle arm. Decades of intense, localized work built substantial new muscle, but removed zero measurable fat from right above that muscle. To test this directly on abdominal fat, another classic study put participants through 27 days of intensive sit-ups. Researchers measured body fat biopsies at 3 distinct locations: the abdomen, the shoulder blade, and the buttocks. Fat decreased roughly equally across all 3 sites across the entire body. The heavily worked abdomen showed zero advantage in fat loss over regions that performed no exercise whatsoever. The underlying biology explains precisely why local fat loss fails. Fat breakdown is triggered by hormones circulating throughout your entire bloodstream, primarily catecholamines like adrenaline. These signaling hormones bind to receptors on fat cells across your whole body simultaneously. It is a broadcast signal sent to the entire system, not a local radio message to one muscle. A flexing abdominal muscle under a fat deposit has no special VIP claim on the fat stored right on top of it. Most videos stop right here and claim the debate is completely settled. But the real story has fascinating complications. Shortly after the 1971 tennis study came out, critical letters were published in the same medical journal. Critics pointed out that a tennis player's non-racket arm is hardly just dangling idle during a match. That off-arm works constantly for stabilization, court balance, and high-intensity ball tosses. It was a valid objection. The natural control arm was never as completely inactive as assumed. Decades later, advanced volumetric MRI technology gave scientists an even clearer window into athlete fat distribution. Researchers used MRI scans on young tennis players aged 10 to 12 and uncovered something truly bizarre. Compared to untrained control subjects, the young tennis players had 48% less abdominal subcutaneous fat. That huge reduction in belly fat was statistically massive and undeniably real. Yet their upper arms, the single most heavily trained area on their entire bodies, showed only 17 to 18% less fat. And that minor arm fat difference was not even statistically significant compared to the non-athletes. Think about how wild that is. The hardest working region showed the smallest fat change, while an untrained region lost the most. This points to the true biological conclusion, which is far more useful than a simple debunking. Exercise drives systemic body-wide fat reduction, but your personal genetic blueprint dictates the order fat leaves. Your fat loss sequence was fixed by biological factors long before you ever touched a gym dumbbell. Biological sex plays a primary role in where your body naturally prioritizes storing and releasing energy reserves. Men are genetically inclined to store excess calories abdominally around their stomach and waist. Women are biologically predisposed to store fat preferentially in their hips, glutes, and thighs. As a general rule, the precise spot where you gain fat first is almost always the place you lose it last. Your stubborn fat deposits are simply lower down on your genetic body fat extraction queue. However, there is a vital distinction about belly fat that almost nobody clarifies. Belly fat is not one single uniform block of tissue. It consists of two completely different fat types. First is subcutaneous fat, which sits directly beneath your skin and is the exact layer you can physically pinch. Second is visceral fat, which sits deep within your abdominal cavity, packed tightly around your internal organs. Visceral fat is far more metabolically active and responds very rapidly to overall systemic exercise, especially cardiovascular training. When you start working out consistently, your body often burns through deep visceral fat long before touching surface subcutaneous fat. So your midsection really does respond strongly to general exercise. It simply responds to total calorie expenditure, not to targeted abdominal exercises specifically. Why does the spot reduction myth refuse to die despite decades of clear scientific evidence? Because training a muscle causes local hypertrophy, making the tissue beneath the fat firmer, denser, and more defined. That improved structural support pushes the overlaying skin out, creating a tighter, visually leaner appearance. People feel that local muscle firmness and mistakenly assume they just burned off the fat right above it. In truth, they built the muscular engine underneath while the total fat covering it remained virtually unchanged. The only genuine method of true spot reduction in existence today is direct surgical removal through procedures like liposuction. Surgical fat removal is an invasive medical procedure, entirely separate from natural human exercise physiology. Every set of crunches you perform builds strong, functional, and healthy abdominal muscle wall strength. Crunches strengthen your core, improve posture, and build the structural muscle you want to reveal later. They simply do not burn off the specific fat blanket sitting directly on top of those muscles. Uncovering those hard-earned muscles requires an overall sustained calorie deficit through proper diet and full body movement. Your genetics control the strict order of fat loss, but you hold complete control over total fat reduction. If you keep dropping overall body fat, your stubborn areas will eventually be forced to shrink as well. It requires patience, consistency, and understanding how your unique biology operates. Stop trying to target specific spots and focus on driving total full body progress. Did you spend years believing crunches would burn belly fat? Tell me in the comments below, and hit like and subscribe for more deep dives into the real science of fitness.